Welcome to Maths and Science Professor channel. We are continuing to look at binomial series. This is the second part. I highly recommend that if you haven't watched the first part of the binomial series problem, you go back to the videos and have a look at the first part, because it will give you a detailed analogy, a step-by-step method on how you can solve binomial problems. But we will go ahead and look at the second example of our binomial series problem 1.002 raised to power 9, and then you are told to use the binomial series formula to expand this one to the power of 9. Now if we can just remind ourselves what the binomial series expansion was. If we have a plus x raised to power n, then the term will expand as follows. We have a raised to the nth power n a n minus 1 times x plus n into n minus 1 n minus we have a n minus 2 x to the second power. Here we have 2 factorial plus n minus 1 n minus 2 a n minus 3 x to the third power. Here we have 3 factorial, and the series continue until you have x to the nth power. Now let's try to solve this problem that we have 1.002 raised to power 9. We use the same formula to expand this. If we put this in the terms of a plus x raised to the nth power, we will have 1 plus 0.02 raised to power 9. And how do you work out this one? You will have 1 raised to power 9 plus 9 1 raised to power 9 minus 1. 9 minus 1, we have 8 times 0.002 plus 9 times 8. You have now 9 times 9 times 1. You will now have 9, 8, and 1 raised to power 7. Here we'll have 0.002 raised to power 2. And this is 2 factorial. 2 times 1. You proceed, and now you have 9 times 8 times 7 times 1 raised to power 9 minus 3. Now have 6 times we have 0.002 raised to power 3. Now we have 3 factorial. 3 times 2 is 6. And you proceed with your expansion. 9 times 8 times 7 times 6. You will now have 3024 times 1 raised to the 5th term. Have 0.002 raised to the 4th term, and we have the 4 factorial as 24. You proceed, and you have 15,121 raised to power 4. We have 0.002 raised to power 5 divided by 120. This is the second factorial, third factorial, fourth factorial, 5 factorials. And then you have you add, you have the next term 6480 raised to power times 1 raised to power 3, 0.002 raised to power 6. The 6 factorials, you will have 50, 40. You proceed, and then you have the second term 362 880 times 1 raised to power 1. We have 0. We have here raised to power 4, 3, and here we have the next one should be raised to power 2. We should have 2 here, so meaning we should have 181. If you work out the terms, 9 times 8 times 7 times 6 times 5, we should have here 181 440. 181 440 times 1 raised to power 2 times 0.002 raised to power 7 over 40. So what you do here, we have the 6 factorial, the 7 factorial, this is the 8 factorial, and the 9th factorial. We will now have the next term plus 362 880 times 1 raised to power 1, 0.002 raised to power 8, 40, 320 plus 362 880, 1 raised to power 0, 0.002 raised to power 9, 362 880. Now let's organize this and see what we have. We work out 9 times 8 is 72. We will have 2 to 72. Here we will have 36. And then you work out 9 times 8 times 7, you have 504. Divide by 6 factorial, you will have 84. You work out 24, 3024. Divide by 24, you have 126. 15,120. Divide by 120, here you will have 126. 60,480. Divide by 720, here you will have 84. You have 181,440. Divide by 5,040, you will have 36. Continue, 362,000. Divide by 40,320, you will have 9. And here you will have 1. Now you work out all this, and then you see what you have. We'll have 1 to the power of 9. Here you will have, let's work out this one. If you work out all this that we have above, you arrive at 1 to the power of 9 plus 0.018 plus 1.44, and you continue up to 5.12 times 10 raised to power negative 25, and then you add all this, and you add all this and find your final answer. If you work out all this in your calculator, you find it 1.018. Let's look at the third example. And in the third example, you have been asked to determine the value of 3.039 raised to power 4. What we can do, we want to place this one, or we want to put this one in the terms of a plus x raised to the power of n. Now first we have 3.039, which can be the same as saying 3 plus 0.039 raised to power 4. And we will then bring 3 out, and then we will have 1 plus 0.039 raised to power 4. And as we proceed, we will divide by 3. When we have 1, it means we have divided this one by 3, and we have 0.039 divided by 3 as well. So you will end up having 3 raised to power 4, 1 plus 0.039. If you divide that one by 3, you'll have 0.013 to the power of 9. Now we will solve this part. We'll have 3 raised to the 4th power times 1 plus 0.013 raised to the 9th power. Let's solve 1 plus 0.013 to the 9th power. Using the binomial series formula or the binomial series expansion, we then have a 1 to the 4th power plus 4, 1 to the 3rd power times, we have 0.013 plus 4 times 3 is 12, 1 to the 2nd power times 0.013 raised to power 2 divided by 2 factorial, that is 2, plus 4 times 3 times 2, that is 12 times 2, we have 24, 1 now raised to power 1, 0.013 raised to power 3 divided by 3 factorial, that is 6. And the last part we have 24, we have 4 times 3 times 2 times 1, 4, this is 4 times 3, 4 times 3 times 2, 4 times 3 times 2 is 24, 4 times 3 times 2 times 1 is 24. We have 1 to the 0 power, 0.013 raised to power 4 over 24. 24 is 4 factorial, that is 4 times 3 times 2 times 1, and that one gives you 24. Now when you work out and arrange this one in a neat way, you will have here, you'll have 6, here you will have 4, and here you will have 1. You then go ahead and work out this one. You'll have 1 to the 4th power is 1 plus 1 to the 3rd power times times 4 is 4 times 0.013. You'll have 0.052. You work out this one, 1 times 6 times 0.013 raised to power 2. You will have 1.014 times 10 raised to power -3. You then work out this one, 1 times 4 times 0.013 times 3. You will have 8.788 times 10 raised to power -6, plus the second, the final part. You will now have 1 times 1 raised to power 0. We have 1 times 1 is 1, so you have this part, and this one will be 2.8561 times 10 raised to power -8. We should not forget that we are supposed to multiply this by 3 raised to power 4. But first of all, we need to solve this. If you solve this, you add all this by a calculator. You find out that your answer is 1.0532. You multiply by 3 raised to the 4th power, 1.0532, and your final solution is 85.2948. Now this is how you use binomial series to expand given terms. Let's rewind this video by reminding ourselves the binomial series formula. If you have a plus x raised to the power of n, using the binomial series to expand this one, you will have a to the nth power plus n a n minus 1 x plus n minus 1 a, n minus 2 x squared, 2 factorial. 2 factorial means 2 times 1 plus n minus 1 n minus 2. Here you will have a n minus 3 x to the third term, 3 factorial, and then you continue to add until you have the x raised to the nth term. This is the binomial series expansion.